Today we can study ideal solution. See, an ideal solution means a solution which obeys Rao's law. A solution which obeys Rao's law. Obeys Rao's law means when we draw vapor pressure against a mole fraction, we will get a straight line. That is ideal solution. Here in this graph, two components A and B. Here XA increases, XA is 1 here and it decreases to 0, and XB is equal to 0 and it increases to 1. That is, here XB increases to 1 and XA decreases to 0. Now this is mole fraction. Mole fraction is always a total 1. That is 1 plus 0 is equal to 1 here also. Now this is P0B, PB. PB increases, reaches here when XB is equal to 1. It is this is P0B. This is P0B. That is vapor pressure only due to the B component. Only due to. Now in this direction, the partial vapor pressure of A increases and reaches this is maximum, that is P0A. P0A, that is pure component. P0A, pure component. Now when this is a straight line, if you get a straight line like this, then we call obeying Rao's law. That is, ideal solution is a solution which obeys Rao's law, and delta V mixing should be 0. Delta V mixing 0 means volume should not be changed. There should not be an increase or decrease in volume. If a two solute 50 ml of a solute and 100 ml of a solvent are mixing together, 50 ml of a solute and 100 ml of solvent, it should be 150 ml, not 149 or 151. There should not be any increase or decrease in volume. That is, delta V mixing should be 0. And delta H mixing should be 0. Delta H mixing 0 means there should not be any change in enthalpy or heat change. Heat should not liberate or absorb. That is, the heat should not liberate or absorb. That is the ideal solution. These are the three conditions for ideal solution. It should obey Rao's law. Delta V mixing should be 0. Delta H mixing should be 0. Obeying Rao's law means when we draw vapor pressure composition curve, vapor pressure mole fraction curve, we should get a straight line as shown in this graph. Now, in this, why there is no change? Because the force of attraction between AA, suppose A and AA are mixing together, there is a BB. B is a solute. B is a solute and A is a solvent. And when they mix, there is a force of attraction between AA force, BB force, and AB force of attraction. Three types of forces are there. If AA force or BB force are equal to, almost equal to AB force of attraction, that is a solute interaction and solvent interaction is almost equal to solute interaction, then it is an ideal solution. So ideal solution of Rao's law, delta V mixing is equal to 0, delta H mixing is equal to 0, and AB force will be almost equal to AA force of attraction and BB force of attraction. For example, a mixture of a solution of a normal hexane and normal heptane, solution of bromoethane and chloroethane, solution of benzene and toluene. This is ideal solution. Now, non-ideal solution. There are two solutions which do not obey Rao's law, are called a non-ideal solution. Non-ideal solutions. Solutions which do not obey Rao's law are called a non-ideal solution. Non-ideal solutions, two types: positive deviation and negative deviation. Solutions showing positive deviation and negative deviation. The first one is solutions showing positive deviation. Solutions showing positive deviation means they do not obey Rao's law. That means instead of getting a straight line in this graph, vapor pressure mole fraction curve, if instead of getting this straight line, they will be deviated towards positive direction. The vapor pressure composition curve will be deviated upward. That is, vapor pressure will be more than that we expect from the Rao's law. That is, do not obey Rao's law. And delta V mixing is greater than 0. Delta V mixing is positive. Delta V mixing will be positive. That is, there will be some expansion of volume. Suppose 50 ml of a solute and 50 ml of a solute and 100 ml of a solvent are mixing, maybe 151 ml. That is some expansion taking place there. And similarly, delta H mixing is greater than 0. Delta H mixing also positive. That is positive deviation. So solutions showing positive deviation, they do not obey Raoult's law. Delta V mixing is greater than 0, that is positive. Delta mixing is also greater than 0, that is positive. The vapor pressure composition curve will be deviated in the that is in the positive direction. It is upward deviation. And example of such a solution is a mixture of a cyclohexane and ethanol. Cyclohexane and ethanol. That is between ethanol and ethanol C2H5OH, there is a hydrogen bonding and cyclohexane. Cyclohexane also there is cyclohexane. When the hydrogen bonded ethanols are there and HCO, HO, C2, H5. Similarly, between these hydrogen bonded, when cyclohexane molecules are entering, there will be some expansion of volume. Expansion of volume will be positive. That is, volume is expanded, volume is increases. Similarly, the heat also liberated. Heat also, delta H is positive. Delta H is positive. Great, more delta H negative heat will be positive. That is, the heat is liberated, more heat. And here F AA, force of attraction between AA or force of attraction between BB will be greater than AB force of attraction. AB force of attraction. That is AA and BB force of attraction will be greater than FAB, AB force of attraction. That is solute to solute interaction or solvent solvent interaction will be greater than solute and solvent interaction. Here in this example, cyclohexane and like attract, like that is cyclohexane, there will be force and ethanol hydrogen bonding, but the only there will be increase in volume. There is force of attraction between AB is lesser than AA force of attraction or BB force of attraction. Next is the solutions showing negative deviation. Solutions showing negative deviation. Negative deviation means when we draw vapor pressure composition curve that is deviated downward, that is triggers negative sign. All that here they do not obey Raoult's law. Delta V mixing is less than 0. That is less than 0 means negative. Delta H mixing also negative. That is also negative, less than 0. In this case, FAA force or FBB force, BB force will be lesser than FAB force of attraction. That is, the solute solvent interaction will be greater. So they come closer, and volume decreases. And heat also, delta H is negative. Delta H negative means heat, it is liberation of heat. That's heat will be here. It is lower heat reactants after solution, lower heat, and solute and solvent will have higher heat. That is delta H is a negative. Delta H is a negative. Now example, mixture of acetone and chloroform. The acetone is CH3 CO CH3. Chloroform CHCl3. CHCl3. There is a hydrogen bonding between these two, hydrogen bonding. So they come closer and volume decreases. That is negative deviation. See, this is a AB interaction. Here weaker. See, positive deviation. Positive deviation. AB interaction is weaker, and negative deviation, AB interaction is more. We already studied here FAA or FBB interaction is more than FAB interaction. In this case, FAB interaction is greater than FAA or FBB. This is a positive and negative. So non-ideal solutions means solutions do not obey Raoult's law. And there are two types of deviation: positive deviation, negative deviation.